Greetings and welcome to the introduction to astronomy. In this week's special topic in astronomy, we are going to talk about the zero age main sequence and try to understand a little more about what that means. So what is the zero age main sequence? Well, if we look at a definition of it, the zero age main sequence is the location of a star on the HR diagram when it first forms. Now that would be the position of that object on the zero age main sequence, and the zero age main sequence itself would be all of those points for all stars of all masses put together. So it would be a single line along the main sequence as you move along here from the bottom left up toward the upper right. And that would be where stars start out on the main sequence. So this is where when it first forms, that is what the zero age in zero age main sequence is. It has just been born, just become a star. So why does a star not remain there? Well, we have to look at what the HR diagram means. Remember, it's a plot of temperature and brightness. So it looks at those two things. Now, those are not constant over the life of a star. They actually can change. So during that star's life, the temperature and the luminosity do change. That's happening to our sun right now. So our sun is about halfway through its life. It is no longer on the zero age main sequence. It's still on the main sequence. The main sequence is a wider band, which allows for some of the stars that have moved off of this. And that's what happens as the star evolves. It moves off the zero age main sequence, eventually moving up to become something like a red giant star up here. But that first stage, that long stretch of the star's life, about 90% of its life that is spent on the main sequence, is relatively close to the zero age main sequence, but not on it anymore. Now, how long does this process take? Well, let's take a look here. Here we see a chart showing the zero age main sequence in the red here. So the line down here and going up toward the upper left is the zero age main sequence. And then we can see times as to how long it takes a star of different masses to evolve off that main sequence. So it might take a star like our sun many billions of years to get a little ways off the main sequence. So while it's not directly on there again, it is still moved a little bit off. It's gotten a little bit brighter than it was when it first formed. Now for other stars, it might only take 10 million years. For a very massive star up here, it's only taken it about 10 million years to start to make an even bigger jump off of the main sequence. And that's why we say this depends on the mass of the star. High mass stars will evolve quickly. Low mass stars will evolve slowly. So they will take a much longer time. And in fact, those very low mass stars haven't even had time to get off the main sequence yet. So the amount of time here given in years, and 10 to the ninth being would be a billion years that it would take for some of these stars to actually get a decent percentage of the way off of the zero age main sequence. So let's go ahead and finish up with our summary here and talk about what we've looked at. And what we've talked about is the zero age main sequence is where a star is located when it first starts fusing hydrogen into helium, when it first becomes a star. When we look at stars of all masses, that gives us the entire zero age main sequence. The stars will begin to evolve immediately and slowly move off the zero age main sequence. So they don't stay there for a very long period of time. And we find that the more massive the star, the faster it will evolve and move off of the zero age main sequence. So that concludes this week's special topic in astronomy on the zero age main sequence. We'll be back again next week for another special topic in astronomy. So until then, have a great day, everyone, and I will see you in class.